Hello students, today we are going to study magnetic field at a point along the axis of circular coil. This is our part second. In earlier section, we have seen part first, magnetic field at the center of circular coil. Today, we will going to study magnetic field at a point along the axis of circular coil. Let us consider, this is circular coil, total length is L. Current I is passing through this circular coil. There is a center O. This loop is having radius A. Now, this loop is divided into small element of the length. Let such element, one such element, dl, and point A is the center of this element dl. Similarly, consider B, same as it is, like A. Now, there is a point B at which we have to find magnetic field. Draw perpendicular to the diameter AB at point O. Point P is a P at distance x from the center of the coil. Now join AP and BP. Let this is R. AP is what? R. And angle APO is alpha. This angle is alpha. This is DB. This is DB. Now, from Boyer-Savarт law, we have dB is equal to nu naught upon 4 pi I dl sin theta upon r square. This equation is first. Here, AP is perpendicular to element dl. AP is equal to what? R. This is not a three-dimension diagram. Therefore, for your understanding, consider this is the circular coil and this yellow portion is a small element dl. Then we draw perpendicular to this element dl. This is R. Then can you see? This is perpendicular. This plane is perpendicular to this element dl. Therefore, theta is what? 90 degree. Then sin theta is equal to 1. Substitute value of sin theta in equation first. Then we get mu naught upon 4 pi I dl upon r square. Direction of magnetic field dB is perpendicular to dl bar. This is dl bar here, dl bar and r bar. Then dB have two components. First one is dB cos alpha and second one is dB sin alpha. This dB cos alpha is perpendicular to axis of coil. This is axis of coil. Means what? Perpendicular to axis of coil. This is what? dB cos alpha. Similarly, dB cos alpha. And this dB sin alpha component is along axis. This is x, then this is dB sine alpha. But if you observe, this dB cos alpha and this dB cos alpha are in opposite direction. Therefore, they cancels each other. Hence, resultant magnetic field B at point P due to circular coil is equal to sum of all components of sine alpha. Therefore, integration dB sine alpha is equal to what? B. Substitute value of dB from equation second. Integration nu naught upon 4 pi I dl sine alpha, not theta, sine alpha r square. From triangle AOP, this angle, this is alpha, this is a, small a. Sine alpha is what? From this triangle, sine alpha is what? Sine alpha means opposite side upon hypotenuse. Which is opposite side? OA is A. And hypotenuse is what? AP, having value R. Therefore, sine alpha is equal to A by R. Substitute value of sine alpha. Then we get B is equal to mu naught I upon 4 pi dl A upon R square into R, A by R, value of sine alpha. B is equal to mu naught I, take constant outside, 4 pi R cube, R into R square into R, integration dl. In part first, we see what is dl. dl is what? Circumference of circle, which is given by 2 pi into radius. Here radius is what? A. Therefore, 2 pi A. Substitute value of integration dl. Then we get mu naught I A upon 4 pi R cube. 2 pi A. 2 2s are 4. Pi gets cancelled. Then B is what? Nu naught I A square upon 2 R cube. From triangle AOP, R square is equal to right angle triangle. Hypotenuse is equal to side square, sum of side square. Then A square plus X square. Or we can write R cube is equal to A square plus X square 3 by 2. Can you understand this step? R square is what? A square plus X square. Then R is what? A square plus X square 1 by 2, taking square root. Then R cube is equal to R square into R. Substitute value. No need to write this explanation in exam. A square plus X square into A square plus X square 1 by 2. If you solve this equation, then we get R cube is equal to A square plus X square 3 by 2. Here is what? 1. 1 this out. 1 by 2. Therefore, B becomes this B. This B. Substitute value of R cube. B is equal to mu naught I a square upon 2 a square plus x square 3 by 2. If circular coil has n turns, if the circular coil have n turns, hence magnetic field due to circular coil having n turns becomes, we just multiply above equation into n, mu naught n I a square upon 2 a square plus x square 3 by 2. This is magnetic field at a point along axis of circular coil having n number of turns. If magnetic field at a center, magnetic field at a center means what? X is equal to 0. Then equation, if this equation is A, then equation A becomes, just substitute x is equal to 0. B is equal to mu naught, first case mu naught n I a square divided by 2 a square plus 0 3 by 2 means what? B is equal to mu naught n I a square 2 a square 3 by 2. Mu naught n I a square 2 into 6 by 2 mu naught n I 2a. This is magnetic field at the center of the coil. Okay, second. If a point P is far away from the center, means what? If this point P is far away from the center, then x is much greater than a. Means a is equal to 0, nearly. Then equation A becomes, the substitute value of a in equation A is 0. 0 plus x square 3 by 2. If you solve this equation, we get mu naught n I a cube upon 2 x cube. This is magnetic field at the point P, which is far away from the center of coil.